Okay, we are going to be continuing with 6.3 on factoring. You can use trial and error, you can use AC method or the box method, however it is that you want to. I like trial and error, the way I would do this problem, but you know, I've had plenty of practice, let me working on a separate sheet. Let's do this here because I know I'm going to have to do it AC method, but here's how I do it. The only way to get 5x squared is 5x and x. Now for 27, okay, the 27y squared, don't let that bother you. Just like you get x squared, it's going to be x and x. Whatever numbers you pick, you're going to use the y's, okay? 27 can be 1 and 27 or 3 and 9. It's one positive, one negative, so I'm just going to put plus 3 and minus 9. And don't forget your y, because 3y and negative 9y is how you get that 27y squared. Don't worry about this yet. We're not even to that. We're just getting this, which is the purple, and the red comes from here. Now we worry about it. It's the outsides plus insides. The outsides, that gives us negative 5x times, not 9, 5x times negative 9y. 5 times 9 is negative 45, and x times y is xy. Then you're going to say 3y times x. That's going to give me a positive 3xy. Doesn't matter what order. This way it just looks in the xy and xy. You wouldn't want xy and then yx. That's just confusing. I always put it in alphabetical order. And that gives us that for negative 42xy. So we factored it. Okay, but let's say you need to do AC method. Okay, remember A is what's in front of your leading. It's your leading coefficient. So that's 5, and your C is negative 27. Oops, I just put A. Let's put A times C. That would help. Okay, so now what you want to do is you want to pick the factors of negative 20. Well, I'm having a hard time with this tonight. It's getting a little late. It's 11:20, and I'm still working on videos. So, 5 times negative 27, and that gives us negative 135. So what I'm going to do is I want to find my factors of negative 135 that add to give us negative 42. Okay? So I don't really know my factors in 135. I know 5 goes into it because it ends in a 5. So what I'm going to do is hit my y equals. Let me clear everything out. Okay? And I'm going to say negative 135 divided by x. Then I'm going to hit my second button and my graph button, which turns it into a table. Second table. And these are all of my factors of negative 27. Now what I have to do is figure out which ones add together to give that negative 42. Okay? Well, I know my number the negative has to be the bigger, because like this gives me negative 6. That isn't going to do it. Well, that's not even a factor. Here we go. 5 and negative 27. That's not going to give me negative 42. So I got to keep going. Oops. Let's try that. Oh, here we go. 3 and negative 45. So I found 3 and negative 45. That adds together to give me 42. I had to search for it a little bit. All right, so what do we do with AC method? What I'm going to do is I'm going to bring this down. 5x squared And I'm also going to bring this down to give me negative 27y squared. And what I'm going to do is I'm going to replace this here with these two factors. So I'm going to put plus 3xy. I'm going to have to move this over. I had a feeling I was going to have to do that. Minus 45xy. Okay, I replace that with that. And now I bring this down, minus 27y squared. Okay, now for terms, we factor by grouping. I am going to group these two together, and I'm going to group these two together. I can factor out an x right here, and I'm left with 5x plus 3y. If I divide this by x, I get 5x. Divide this by x, and I get 3y. I am going to factor out a negative 9, okay, actually a negative 9y, and I end up with a positive 5x plus 3y. And notice these two match. Now I can pull out the 5x plus 3y, and I'm left over with x minus 9y. And you'll notice that's the same thing I got when I did trial and error. Okay? So it's okay. It may take you a little longer, but the object is to get the problem right. Now, the other way you can do this is you could have done the box method. Which is still a form of the AC method. You put your first term right here, 5x squared. You put your last term right here. And I need to make that smaller or make my box bigger, one of the two. I'll try this one, make it smaller. 27y squared. And you know how we replace this with these two? That's all you're doing. You still do the factors just like you did here. And it doesn't matter which one goes where. I'm just going to put the 3xy here, and I'm going to put the negative 45xy here. And I needed my box to be a lot bigger. I can't write that small. Ugh. That is awful. Sorry. I'll try to make my next box bigger. Okay. Now you're going to factor each row. So right here, I can factor out they both have an x in common. Well, now I'm going to do the bottom row. And because this is negative, I'm going to factor out a negative, and 9 will go into both of them, and so will a y. Now I'm going to do it by column. They both have a 5x in common. And then this, yeah, I'll just do it like this. Okay. Right here, they both have a plus 3y. They both have a 3y in common. And because it's positive, it'll be plus. So 5x plus 3y and x minus 9y. And it does not matter. You can have x minus 9y and 5x plus 3y because of the commutative property. Okay? So it's the same thing. It doesn't matter. All right. Factoring a trinomial with higher exponents. All right. So, first of all, what I notice is this is x to the 4th, and that's an x squared. So what we're going to do is we're going to have an x squared here. All right, but still we're going to do AC method. You don't even have to know that. So you're going to say 3 times a negative 30, and we get negative 90. Factors of negative 90 that add to give us our middle term of negative 13. Okay. Before I even started this, I would have liked to have seen, or liked to have tried if they have a monomial. Okay. Unfortunately, 3 will go into 3 and 30, but it won't go into 13. So we could not factor out a monomial. Okay, so we had to go to AC method. Now we need to find our factors of 90 that add to give us negative 13. So you go into y equals negative 90 divided by x. It's always this number divided by x. Second table or second graph. Okay. Our larger number has to be negative because that's the only way we get a negative 13. This won't give it to us. That gives us negative 27. 5 and negative 18. That gives us that negative 13. Okay, so I'm going to put 3x to the 4th here. Find a red pen. Here it is. It's hiding. I'm going to replace this with these. So it's going to be plus 5x squared minus 18x squared. And then I'm going to bring down my minus 30. Okay, we are going to factor by grouping. I'm going to pull out an x squared. And I'm left with 3x squared plus 5. Sorry, I didn't do that up here with my red pen. Here, I'm going to factor out a negative 6. Yep, that's all. And I'm left with a 3x squared plus 5. Now they both have a 3x squared plus 5, so I can factor that out. And I am left with x squared minus 6. Okay. Now the only thing you would need to do is make sure that you can't factor either of these any further. Okay, but you can't, so we're done. If you did the box, I'll make my box bigger. Oops, that doesn't look like a box, it's a crooked line there. We'll fix it. A little bit better. Watch, I'll just make my numbers bigger, it still won't fit. Okay, you still put this 3x to the 4th here, the negative 30 here. You replace this with 5x squared and negative 18x squared. And now you just factor by rows. These both have an x squared in common. These both have a negative 6 in common. Now your columns. They both have a 3x squared. And right here, they both have a 5. So it's 3x squared plus 5 and x squared minus 6. And again, it can be x squared minus 6 times 3x squared plus 5. Okay, right here. Factor completely. These are the, right there, that's the important word. You've got to break it down as far as you can. When I look at this, I don't like any of these because it's bigger numbers, but I can get them down to smaller numbers. I can pick the largest number that will go into 12, 34, and 14, which is 2. I can't pull any x's out, but I can pull out a y, because they all have a y in them. I'm left with 6x squared right here, minus 17xy. I'll put my parentheses. And right here, I have plus 7y squared. Okay, now I have to look to see if this will factor further. Okay, you can do it by trial and error, you can do it AC method, you can do it by box method. I don't care. I'm going to do box method this time. If you like this way, then do it that way. I don't really care. It doesn't matter. However you like it. 6 times our C, which is 7, which gives us 42. Factors of 42 that add to give us 17. Okay, so go under your y equals button and you put 42 divided by x. Oops, let's try that again. Divided by x. Okay. Second graph. There's a glare and I have to keep moving my calculator. It will only, the light won't, isn't bad a glare here, but if I move it so you can see the buttons, then you can't see the screen. So that's why I have to keep moving it. Okay, so we're looking for a negative 17. Well, look at all these. These are positives, so they both have to be negative. That gives us negative 23. That there gives us negative 17. So it's negative 3 and negative 14. Oops, and I did not put a negative right there. I just put it, I saw it here, but I didn't put it over there. Sorry. Okay, so let's do the box method this time. But if you want to do the other way, that's perfectly fine. There's no rules. It just says factor. We're going to put 6x squared here. And we're going to put 7y squared right here. And that's from this point right here. Now, I'm going to replace these, the 17xy, with negative 3xy. Because remember, it's got to match this. And a negative 14xy. Now you factor by rows and then by columns. Right here, or see what they both have in common. They both have a 3x. Here, they both have a negative 7y. Here, they both have 2x. And here, they both have just a negative y. It's negative because of that. So, this should factor like this. 2x minus y. And 3x minus 7. Minus 7y. Okay, now, notice I kept this 2y out there. You have to have it because when you multiply all this out, you should end up with our original equation. Now, just to check to make sure this gives us that, you use FOIL. Or you distribute the 2x, then distribute the negative y, however it is that you think. This gives us 2x times 3x is positive 6x squared. Outside's negative 14. Inside's negative 3xy. So that gives us negative 17xy. And then negative y times negative 7y gives us a positive 7y. And now remember, when you multiply these two, it gives us this. So then you have to have this 2y out there in order to distribute it to end up with our answer. Okay, Now, we are going on to 6.4. Oops, wrong sheet. That's my other class I had to do a video on. Factoring by special forms. The one special form that you need, this is a very important section. If you can learn it, it's going to make your life so much easier. The first thing we're going to talk about is our squares. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 is 49. 7 squared. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Most of you already know those. Now, I think you need to know through 15 squared. Obviously, somebody else does because they made these notes up. You will see these used a lot in math. It will just make your life easier if you don't have to use a calculator. It's much easier to know 3 squared is 9 than to go 3 times 3 on your calculator, 3 to the second power on your calculator. All right, 11 squared is 121. 12 squared is 12 times 12, which is 144. 13 is 169. If you know 13, you can figure out 14 because all you do is switch the 6 and the 9 to get 196. And then 15 is 225. 15 squared. Okay? That is just so much easier to memorize them than to have to go on your calculator and do 15 squared. Okay? All right. So, the first form that the special form is called the difference of 2 squares. This is the important thing. You have 2 terms that are perfect squares with a minus sign. It has to be a minus sign. It cannot be a plus. Okay? If it's a plus, it won't factor. Okay? So here, the way what this says is, this is a perfect square. You can say x times x. This is a perfect square, 2 times 2. So, you get x plus 2, x minus 2. And the reason that is when your signs, when you have a difference of 2 squares, your middle term disappears. FOIL, you get x squared. Negative 2x, positive 2x, that gives us 0. And then 2 times negative 2 gives us a negative 4. This seems to stump people. Most of you guys can get this. If it was x squared minus 49, most of you will be able to do x plus 7, x minus 7, or x minus 7, x plus 7. Okay? That's a no-brainer. But for some reason, when I throw this on a test, people get stumped. This is a perfect square. The square root of 81 is 9. Square root of x squared is x. So you have 9x and 9x. That gives you 81x squared. And then the square root of 49 is 7. So it's 9x plus 7, 9x minus 7. The middle term will disappear. This gives us 81x squared. This gives us a negative 63x, positive 63x, so those cancel. And then 7 times negative 7 gives us a negative 49. If you should see anywhere in these problems something that looks like this, x squared plus 25, this is known as prime because it will not factor. There is nothing that has 2 terms where it's a x squared and a constant. If that's a plus sign, it can't work. Okay? Some people are going to say x plus 5 and x plus 5. But when you do FOIL, this gives you x squared plus 10x plus 25. I just kind of skipped to the answer. If you went to minus 5s, You know, if you did 1 plus and 1 minus, that would not give you a plus 25. It gives you a negative 25. If you went minus and minus, that's going to give us a negative 10x in the middle, plus 25. All right, right here, still perfect square, 3, here, 4x to the 5th, because 4x to the 5th times 4x to the 5th gives us 16x to the 10th. So this factors as 3x plus 5x squared and 3 minus, God, I think I said that wrong. It's late. 3 plus 4x to the 5th times 3 minus 4x to the 5th. I have no idea what I said, but it didn't. I don't think I said that. Sorry. Right here, both are perfect square with a minus sign in the middle. Square root of that is 5x. Square root of that is 2y. So 5x plus 2y and 5x minus 2y. That's going to make, when things look the exact same, but the signs are different, the middle term disappears. Okay. Here we need to factor completely. So we are going to factor out a 3x at first. And we are left with 4x squared minus 1. Difference of two squares. Perfect square 2x, perfect square 1. So 3x, 2x plus 1, 2x minus 1. And again, it can be 2x minus 1 and 2x plus 1. It doesn't really matter. Don't forget the 3x. If you forget that if you forget to write it, this times this only gives you this, not that. Okay. Right here, some of you are going to say it's prime because it's plus sign, but it's not, because I can factor out a 5. And I get 16 plus 25x squared. That is factored. I made it look different, but that's as far as it goes. There is no rule with a plus sign, only a minus sign. So you're done. Now, had this been this to begin with, it would have been prime, but it wasn't. It looked like this. So we were able to factor out a 5. Okay. This is one of my favorite problems to put on a test. Something like this. It's a bad asterisk. Pretend like it's good. And here's why. Perfect square, minus sign. Square root of this is x squared. Square root of this is 9. So, x squared plus 9, x squared minus 9. You'll see it on a test, and some of you will leave it like that. But it is factored. It's not factored completely. And here's why. This is a difference of two squares. This cannot be factored any further, so it's x squared plus 9. But this, however, x plus 3, x minus 3. Okay. So this factors like these two. All right. I like that problem. Make sure you are always checking for that. Hint, hint. Okay. Perfect square trinomial. We learned this last in chapter 5, and I said we were given this, you went to this, and you ended up this. And I said, if you can learn this, it will help you later. Doesn't mean that you have to, but you'll use it later on in this chapter. You can just factor it. however it is that you factor, trial and error, AC method, whatever. I don't do AC method on these because leading coefficient's 1, but I look at it and go perfect square of x, perfect square of 3 gives us 9. When I multiply these two together, multiply it times 2, I get that. So I know this factors as x plus 3 squared. And that goes back to when we learned this, okay? That helps you with it here. Right here, perfect square, perfect square. So the first thing I'm going to look for is a perfect square trinomial. This gives me x, this gives me 8. Does 2 times 8 times, well, it's 2 times x times 8. That's going to give me that negative 16x. So this here is going to factor as x minus 8 squared. I know it's a minus because of this sign right here. This was a plus because of that sign. Okay, again, perfect square trinomial, 5x. Here it's 36. Well, no, not 36, it's 6. Let's try that again. Square root of 36 is 6. This gives us 30x times 2 gives us negative 60. So I know it's a perfect square trinomial. 5x and 6, I know it's a minus sign because of that symbol right there. Alright, factoring perfect square trinomial in two variables. Same thing. 4x, 5y. The only thing I got to make sure is does it give me 40. Multiply these two together and you get 20xy. Multiply by 2 and you do get 40xy. So this is going to factor as 4x plus 5y squared. And I know that it's a plus because of that. Okay, now factoring the sum or difference of two cubes. I will not put this on the test, but you will see it in your homework. Okay? Again, you will see it in your homework, but I will not test you on it. All right? First of all, though, some of this I know, some of it I don't. Okay? But I do want you to learn 1 through 5 cubed. Okay? 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Now the rest of them, I don't really have them all memorized. When I see it, I can recognize it. 16 is 216. I think this is 343, but I'm going to check it on my calculator. Yep. It's 343. I don't know. 8 cubed gives us 512. 9 cubed is 729. And I do know that 10 cubed is 1 with 3 zeros. Okay? So the important ones that you really make your life easier are these. Now again, you have a calculator, you don't have to know it, but it just makes your life easier in other math classes. Now, I know this is a sum of two cubes. This is a perfect cube. So my a, if I took the cube root of x cubed, it gives me x. My b is a cube root of 8, which is 2, because 2 times 2 times 2 gives you 8. X times x times x gives us x cubed. Okay, so this formula right here, because this is plus, we're going to use the top one. Okay, so how this is going to factor is you take your a and you add it to b. And in this case, our b is 2. Okay, that's what that says. Now, you square your a, so it's x squared, minus a times b, so it's 2 times x, or x times 2, which gives us 2x. and then it's a plus b squared. B to the second power is 4. Now, these signs, we use this acronym SOAP. Same, opposite, always, positive. Same means these two are the same. Opposite means these are opposite. This always positive. So, same, opposite, always, if I could spell, always positive. Okay. Right here, perfect cubed. Cube root of 27, here's 27, it would be 3. 3 times 3 times 3 gives us 27. The cube root of y cubed is y. Y times y times y gives us y cubed. So, our acronym is SOAP, so it's same. You're going to take your A, which is 3, minus your B, which is y. That's what that says right there. Now, you're going to square your A. That's what this says. So 3 squared gives us 9. Opposite sign, which is plus. Ooh, that's a bad plus sign. I'm trying to straighten my paper up, and it's not wanting to move on my desk. It's still crooked on the screen. Plus A times B, so it's 3 times y gives us 3y. Always positive, so it's plus, and you square your b, so it's y squared. If you were to multiply all this out, if you multiply this, you'd end up with this. If you multiply these two things, use the distributive property on x, then the 2, you'd end up with that. Again, you'll see it in your homework, but you're not tested on it. Okay. In 6.5, okay, 6.5, it's just giving you strategies, okay? The first thing you always look for is to factor out a greatest common factor. Then you determine, then I look at it and go, okay, if it's 2 terms, is it the difference of 2 squares? Is it the sum of 2 cubes? Is it a difference of 2 cubes? Okay. If there's 3 terms, try it like this here. Okay. See if it's a perfect square trinomial. So basically, on number 2, you decide whether it's a special type. If not, then you just factor it. Okay. If it's got 4 terms, you do it by grouping. And then check to see if the problem can be factored again. Always double check. You can always check your answer by multiplying. So like in here, when I look at it, I go, okay, there's 2 terms, so, and there's a minus sign, so I'm looking for perfect squares. First thing I'm going to do is factor out a GCF. In this case, 4 goes into both of them, and so does x squared. So here I am left with x squared minus, here when I'm left with 4. Okay, well, I notice this is a difference of 2 squares. So I'm going to factor that. It's 2 terms with a minus sign. The way to get x squared is x and x. The way to get a negative 4 is plus 2 minus 2. Okay. So notice I did make sure that it could factor again. Or, you know, that's to always double check that. Now, if I wanted to check my answer, I'd multiply these out, and I'd get this. Then I'd multiply this times this, and it would give me that answer. Right here, I'm going to factor out a 3, and I'm left with x squared minus 2x minus 15. At this point is where you can, if you want to, factor by AC method, even though I usually don't because there's a 1 there, but it's perfectly fine. It's not going to do anything. I just do trial and error though. The only way to get x is x times x. Okay? To get 15, I can get 1 and 15 or 3 and 5. I do know that the signs have to be different because of this. So I would just put in plus 3 and minus 5, and then I would check to make sure I get 2x. Outsides plus insides. Negative 5x, positive 3x gives me negative 2x. But you can use AC method if you want to. It does not matter. Oops, that's a really bad rectangle. Even if I fix it, it's going to be really bad. Okay. But you can use a box method. You can use whatever on this. It's still similar to the AC method. Okay, and I'm going to do one more. I'm going to factor out a GCF, which would be 7x. And I'm left with x to the 4th minus 1. Two terms with a minus sign. I'm going to look to see if it's a perfect square, and it is. The square root of this is x squared. Square root of this is 1. So, again, x squared, right? Perfect square, 1. 1 times 1. So, I'm going to get x squared plus 1 and x squared minus 1. Okay. This is good. This one here cannot be factored because it has two terms with a plus sign. This has two terms with a minus sign. Doesn't mean that it will factor, but you need to see if it's a perfect difference of two squares. Well, the way to get x squared is x times x, and the way to get 1 is 1 and negative 1. So it is the difference of two squares. So I have to go one step further. I have x squared plus 1, and then this one is going to factor as x plus 1 and x minus 1. And now it is factored completely. Okay, so that's it. I will pick up with this in next class.